Okay, you all know that magnetic field is a vector quantity, so which means it has a direction. So to determine the directions of a magnetic field due to a conductor carrying current, so we have different rules here. So first, as we have seen here, we will discuss first about the first rule, that is right hand thumb rule. Okay, so now what does this right hand thumb rule says? So this right hand thumb rule says like this: if we hold a straight conductor, suppose this is my straight conductor, I hold it with my right hand in such a way the thumb points in the directions of current. Now, as you can see here, these fingers, these call fingers here of my right hand, now these call fingers will represent the directions of the magnetic field around the straight conductor. So therefore, if this is my straight conductor carrying a current in this way, then according to this right hand thumb rule, the directions of the magnetic field are concentric circle, okay, around the wire in this way. So that is the first rule to determine about the directions of the magnetic field. Okay. Now, second rule is Maxwell corkscrew rule. So what does this Maxwell corkscrew rule says? Okay, according to this rule, if you take a right-handed screw, suppose this is my right-handed screw, and let's say if this is my wire, and it carries a current in this direction. Now if I rotate like this, if I hold the wire in this way, if I rotate the wire, that means, sorry, if I rotate the screw, right, in the clockwise direction, now you will see as you rotate the screw, what happened? Now the screw is moving inward towards the boat. So that directions of rotation, or the directions of movements of the fingers, right, or the directions of movement of the thumb in this case, will give you the directions of the magnetic field of a straight current carrying wire. So for straight wire carrying current, we have two rules. One is a right hand thumb rule and the other is Maxwell corkscrew rule. Okay. Now, the third direction is about the magnetic field due to a circular current carrying loop. Okay. Okay. Looking at this figure, now we will determine about the directions of the magnetic field due to a circular current carrying loop. Alright. Okay. So this is a circular loop. This is my circular loop which carries a current in the anti-clockwise direction. Now I want to determine about the directions of the magnetic field due to this circular loop carrying current. Okay, so here when you look at the ends of the loop, that means near this end, where is the directions of current? Okay, look here. We know the loop, it is like this. The loop is like this. So as the current is passing through the loop, okay, suppose that, okay, it's difficult for me to show here because I need a three-dimensional picture, but you have to think or you have to imagine about this. This is my circular loop. So at this end of the loop, what will happen to the directions of the current? So as the current is moving, right, it comes here. So as it comes here, what will happen? The directions of current is directed outward, away from the boat. So as the current is directed outward, away from the boat, so look here. My call fingers will give you the directions of magnetic field. So these magnetic field, they are like, a concentric circle, and these concentric circle, right, as you move towards the center of the loop, they becomes larger and larger. That means the curve, the curve, it is large in this case. So the curve becomes larger and larger. Okay. And at the center of the loop, you will find that this curve here, this curve, right, as you move away from this point of the loop, then you will find these magnetic field lines here are parallel to each other. Okay, so similarly, if you look at the other end of the loop, okay, as the current is passing in the loop in this way, so inside, I mean at this point, the current is going inside. So as the current is going in this direction, okay, look at my thumb. The current is represented by my thumb, and these are the call fingers. So my call fingers now, they will give you the directions of magnetic field at this end. So the magnetic field at this end will be a concentric circle. Okay, all right. So similarly, as you move, or if you expand, or as you move the concentric circle towards the center of the loop, what will happen? These concentric circle becomes larger and larger. And finally, near the center of the loop, these concentric circle they become a straight line. So this straight line means that at the center of the loop, the magnetic field is uniform. Okay. So please remember this point, that the magnetic field at the center of the loop is uniform. Okay. And at the center of the loop, again, to determine about its the directions due to a circular current carrying loop, we can use right hand thumb rule. So according to right hand thumb rule, right, at the center of the loop, if you imagined now my call fingers represents the directions of current, then this thumb, right, it is like the axis of the loop. Okay, this thumb, it is like the axis of the loop. Now the magnetic field at the center of the loop will be perpendicular to the plane of the loop and passing through the center of the loop. Okay, I think this is clear. Right. So this is all about the how to find the directions of a magnetic field due to various shape of conductors.